Alright students, I just wanted to make a quick video on floating angles, and notice we have a bunch of floating angles. Get it? Anyway, that was my joke. So let's go to number 5 from 9.7, and the reason I like number 5 is because it's got so much stuff going on with it, and it's actually got so much stuff going on with it that it's hard to figure out where to start. So what I'm going to start with is the things I find really easy are inscribed and central angles. So I'm going to look at this inscribed angle. There aren't any central angles. We don't have anything in the center here. But I have an inscribed angle here. Remember, an inscribed angle has its vertex on the circle. And if I know the inscribed angle, I know the intercepted arc. And to find the intercepted arc, and I know this kind of gets a little confusing here, is follow from the vertex, follow the leg or the side of this angle all the way to the circle. So there's this point here, and I'm going to go from the vertex over to here, to this point. So this is the intercepted arc, this whole thing. So in red, I've highlighted it. That's our intercepted arc, and that's our angle. So I know the angle is half the intercepted arc, or the arc is twice the angle. So what's 39 times 2? That's 78. Now, if I know the entire arc is 78 in red here, and I know this section here is 44, so I know the two of them combined, x and 44, have to equal 78. So x is simply 78 minus 44, which equals 34. So I know that part of the circle now. So let's try and find something else. What else can we find? So now that we know that that arc here is 34 degrees, we can find this angle F. This is a floating angle outside the circle. Now, I know this wasn't part of the original problem, but let's try and solve it anyway. So I'm going to look at this red arc and the blue arc, and a floating angle outside the circle is simply half the difference of the intercepted arcs. So I know the red arc is being intercepted and the blue arc. So I'm going to subtract the small one from the big one and then divide it by 2. Half the difference. So 72 minus 34 divided by 2 is my angle F. So that's 38 divided by 2, which is 19 degrees. So that's a floating angle outside the circle. So that's our angle, and it's just outside the circle. It's half the difference between these two arcs. Now, I want to find something else. Now I need to find y. So if I know basically all of the circle apart from y now, and I know a circle is 360 degrees, so if I add up those 4 arcs that I know so far, that's 210. So what do I have left? Well, 150 degrees. So 360 minus 210 is 150. So that arc y, which is this arc here, is 150 degrees. So now we know this much of the circle. So we know all of the arcs. And we actually know this angle out here. That's 19 degrees as well. Now, I want to find z. Now I could use the angle sum theorem since I know that's 19 degrees, but I want to use my floating angle formula. And I need to actually find the average of these two arcs. The average of the red arc, which is 60 degrees, and the average of the blue arc. So remember, it's the intercepted arc. So a lot of common mistakes are students will use 150 degrees and 60 degrees as the average, which is 210, and then think that the angle z here is 105. But the problem is the arc actually goes all the way to here. So follow the angle and follow that arm and make sure you're grabbing the entire arc. So if this is my Z here that I'm looking for, make sure you're going to the point on the circle and going all the way around to the other side of the angle. Okay? So 34 and 150 is 184. So now I can use that to figure out the average or the middle. Remember, it's kind of like being on the number line. If I'm starting at 60, where's the middle point in between 60 and 184? That's what I'm looking for. So 184 plus 60 divided by 2, that's 244 divided by 2. So angle Z is 122. Now, what if we use the angle sum instead? The angle sum of this triangle here. Hopefully it adds up to 180. Now, what was this angle again? It was 19 degrees. So 19 plus 39 plus 122, does that equal 180? Sure, it does. So we're right. Okay, so hopefully this helps with all of the floating angle problems. If you have any other questions, please let me know.